Good morning, everyone. Nathan Kroll here from Data Ladder, Director of Product Development. Waiting one more minute to have one other person join. Okay, good morning, everyone. Nathan Kroll here from Data Ladder, Director of Product Development. I wanted to thank everybody for taking time out of their busy schedules to join us today. We're going to be going through best practices in data matching for SLDS systems. Really quick, just to let you know, there is ability to go through and ask questions during the webinar, and feel free to ask the questions or put them into the chat. We'll see them and we'll answer them as well as we can. Someone asked if we'll be able to get a copy of the webinar after we go through the presentation. The answer is yes. We're actually recording this, so we'll send out a recording to everyone to make that accessible. Also note that everyone on the line is muted, so there's no chance for anyone going and talking and letting everyone else know who they are. So all that information will be private. In addition to all the questions will be private as well. But feel free to ask questions via the chat as we go through, and we'll answer them as we see them come in. And also we'll have a section towards the end of the presentation as well. So first off, just talking through all the topics that we're going to go through today. First off, we're going to do an introduction to Data Ladder and who we are. Then we're going to talk through data matching, the issue, taking a look at actual record in a database as an example. Talk through a great case study example, A Tale of Two Cities, and talk about the impact of bad data matching on policy decisions. Then we're going to talk why minorities are underrepresented in current SLDS systems, as well as data matching in general. And with that, how to explain to sponsors what the impact of the bad data matching is on policy decisions, personnel, etc. Once we get through that, we're going to talk through why are 10% of matches typically missed in most of the best SLDS systems and what you can do about it. And we'll also take time for a Q&A. First off, talking through our company. We focus on data matching and cleansing programs, and we target them towards business users and business problems. In this case here, business being analyst type level, reporting, not necessarily just IT people. We aim to have a very good graphic user interface so people can see the impact of bad matches, can see how they can go through and change them and affect them, and also be able to identify where bad matches are in their data. We also help link together internal and external data. So within everyone's current business or organization, you have data that you own that is inside of your own organization, and you're very comfortable with it. We provide high-quality data matching software, so if you need to go through and try to find duplicates within your own data, or you want to try to find matches outside your own data set, for instance, if you have Department of Education data and you want to link that to Department of Labor data, our software is ideally suited for that. concentrate a great deal on usability. Very visual design, lots of reports, lots of colors, etc. Saving the settings for reuse. Make sure that we're compatible with everything out there in terms of file formats, all the way from text, Excel, up to Oracle, SQL Server, etc., as well as ODBC. Industry-leading technology. We do a very large investment in R&D. We'll take you through some benchmark studies later on in the presentation, comparing ourselves to typical in-house solutions, as well as some of the other larger players in the marketplace like IBM and Dataflux that have excellent solutions but don't focus on data matching in particular. Do a great deal of semantic contextual matching, which particularly helps for unstructured data. And we're consistently focusing on improving our own internal algorithms around fuzzy, which is records that are spelled the same or similarly, and phonetic matching, which is words that sound the same. Always take a look at client feedback. We have a very human-centric design where we try to make sure that we reduce the number of clicks and we increase the instant understanding that we have within our graphical user interface. From a support perspective, we always have real people assigned with our account managers. Share knowledge, over 2,500 installations in 31 countries. We've done SLDS or similar implementations across 13 states and 5 other provinces within Canada, Australia, and the UK. And I've also done a great deal of work with the federal government. And always look for new ways to save you time and money in terms of matching accuracy or data cleansing. Really quick, testimonials here. Not going to read through each one. Essentially, we worked with organizations of all shapes and sizes. We've done business with companies that are only 5 people, and we've done business with Fortune 10 companies. We've currently worked with approximately 14, a dozen different states within the US, as well as multiple federal agencies like Department of Treasury, Department of Transportation, etc. Outside of the government space, we've done a lot of work with consulting companies, KPMG, large insurance companies, Zurich, etc. So the main takeaway here is we've worked with organizations of all shapes and sizes, and we've seen the problems that are inherent with trying to do data matching in large data sets. The reason why this is applicable for talking about SLDS, SLDS is has a very lofty goal in general within states of being able to connect the data together across the various government data sets, Department of Labor, Department of Education, etc., to get a unified view of their students. And that can be very, very difficult, especially because you're dealing with systems upon systems upon systems. What I mean by that, you might go through and you might have a single repository for K through 12, but you might have multiple data repositories that you're getting from other in-state colleges and universities, as well as external state colleges and universities. And this issue of matching and bringing that data together, very common in the world, very common with government organizations as well as private organizations, and is something that we have a great deal of experience with. So thank you everyone for making your way through that piece. Now we're going to talk through data matching. What's the true issue? So here we're going through and we're taking a look at just 3 records within a database. And we're taking a look at Jennifer Smith. And as you take a look at this data, especially if you deal with data a lot, you're going to recognize a lot of these issues. You'll see that we have various nicknames going on. We have Jenny, we have Jen, Jennifer Smith. We have middle initial before the last name, various addresses, but the addresses are not necessarily in the same format, especially when you start getting into things like address to, suites, etc. Even at the city level, we have city name, city abbreviation, etc., and that carries all the way through all the other geographic data, county, zip code, etc. And then even something as simple as date of birth, just from a pure formatting perspective, can be very different between databases. So overall, one of the biggest issues we have, all of us, when we're looking at data, is that a person can go through and take a look at these records and they can tell that this is all the same record, this is all the same person. But the difficulty is a computer would have a hard time deciphering this information. The reason for that, computers are looking at something in an exact way. Either it's a 0 or it's a 1. But the real world doesn't work like that, especially when you're dealing with people, when you're dealing with names, and you're dealing with all of the inherent ways of interpreting those names that exist out there in the real world. Now, one thing that I always like to point out, because many times within an organization you feel and are dealing with your own data. We've seen data across many companies, many industries, many states, and I want everybody to even just feel a little bit more comfortable that the issues you're encountering are universal. Within 100% of our clients, when we're looking at real-world data sets, we find unexpected data quality issues within 5 minutes, including the data sets you're the most familiar with. The reason for that is we focus on it. We have great tools for doing instant data profiling and memory profiling and being able to find those issues right away. So I always like to point that out before we start the exercise or even start talking a little bit deeper, just to let everyone know these are common issues. It's not something that is just because someone was doing a bad job or your organization or because of the way that the colleges interface with K through 12. It is universal throughout all organizations that are dealing with a lot of data being over 10,000 records, and in many cases, many states are dealing with millions, if not tens or hundreds of millions of records. Another thing to point out, even in automated data feeds over time, if you think about a database and what happens in terms of entering in Jenny Smith's record, over the lifetime of that record, over a full longitudinal view of Jenny Smith, there might have been certain changes in terms of personnel, who's doing the data entry within a particular system, or even what we think of as a system might have been 3 different systems over the past 30 or 40 years, or even longer in some cases. So there's a certain amount of a life cycle of the system where even if you know how it operates today, in 2016, you might not be aware of what happened all the way back in 1975 with the exact same, in theory, database. Another issue that we see very often, empty values within fields that are supposed to be required. Even things like automatic identifiers or sequential identifiers, social security number, your own internal state unique IDs, etc. Another piece that we take a look at right away, how distinct are the values? What percentage are filled in? That helps us identify if we're going through and we're trying to match up information between Department of Education, Department of Labor, and we notice that, well, first name isn't filled in 3% of the time, we know that we have to be more creative to try to find those matches. And we know that we have an issue that we need to go in and address. Do we see numbers where there should be letters? 0 versus O. Many times blank spaces within the data itself. OCR reading issues are a great example of that. William versus Will space IA space M. Very common, especially when you're taking a look at test data, data that might have been scanned, and you're looking at information that might have been self-entered by the individual as opposed to something systemically fed. Take a large range of look at the values and take a look at simple things like what's the range of values that we have within our date time fields. Do we see that we have individuals in our school system that, according to the data, are 2,000 years old? Maybe there's some issues there that we should take a look at before taking a look at our matching. And of course, the ever-present leading and trailing spaces, etc. So here, we're going to start with bad record linkage, a tale of 2 cities, and this is just an example that we always like to talk through. So we're taking a look at 2 cities. City A going through, doing the reporting, and we were taking a look at college attendance. This is actually a state example. They're looking at college attendance within a particular city, and according to the SLDS system that had homegrown data matching, they had a 22% college attendance rate. Very low, approximately half of the U.S. average, which of course is an issue. In this particular case, they paid a great deal of attention to the data, even at that level. And then we had City B. City B had a 41% college attendance rate, much more in line with normal, much more what you'd expect within a large city, etc. These are the same city. The only difference was the record linkage. The city in this example had many issues that led to the poor record linkage. They had a fairly large proportion of immigrant groups compared to other cities. They also had some issues with reporting within one of the main colleges in the area that led to this. But even with those issues, those exact same issues, City A was before. Once we went in, we found that we were able to almost double the amount of matches that we were able to find between the higher ed and the K-12 systems. And of course, it's a very, very different result. And you can imagine the havoc that this caused once we went through and were able to go through and identify this. To the state's credit, everything was very open. There was no attempt to hide this. It was a widely talked about problem. Obviously, we don't want to mention which state it was, and we have NDA in place for that. But they were nice enough to allow us to say, yes, we can go through and talk about this example, because they know, especially after we took them through other case studies from other industries and even things in the private sector, that this is just a common issue. This is not anything to do with them. This is just what happens when you're dealing with a lot of data and trying to do a population study like SLDS. Population study being trying to take a look at the entire population of a state or a region or a country and come up with some kind of a analysis. Now, the impact on the policy decisions, you can imagine, can be quite bad and can potentially cast the entire SLDS system itself in a bad light just because of these bad data matches. And many times these systems, years of effort, millions, tens of millions of dollars, all disrupted potentially to a great degree because of bad data matching. Now, many of these systems have homegrown matching, and what we've seen in the cases where we've come in after the fact, especially if they had a homegrown system, was that they were giving a poor report card to individuals or cities, etc., that didn't actually deserve it. And that goes back to the Tale of Two Cities example. The other piece, budget allocation. Now, let me just say, there was no real harsh decisions that we saw taking place. There's enough, pull within, education, teachers' unions, etc., whether nothing horrible was going to happen, even if they went through and were acting on the bad data. But what we did see was that the budget allocation was really probably, misspent. Because they took a look and they thought, well, these particular areas are having much bigger problems. They started to make assumptions because they didn't have very good data. They didn't have early childhood information then. And they started allocating money to programs where they definitely would have done things differently if they had had the correct data. And that usually affects a lot of special program funding. Another piece that we've noticed is that it also disproportionately affects women and minorities. We'll walk through the specifics on that. And we'll also walk through specifics to let everyone know, talk about other country examples. This is by no means a U.S.-specific problem. This problem exists in every country that we've ever gone to and done business with. But one of the biggest issues, because the personnel decisions, budget allocation, those are all things, kind of short-term. They can be fixed, etc. The biggest issue is the lack of trust in the SLDS system, because as everyone knows, once you have some kind of an issue of trust with any organization, particularly a government organization, people will bring up that example forever, and it will consistently come back in a way to haunt you. If people were aware of the issue, they'll always bring up, okay, well, we're trying to make decisions, we're doing research on this, we're doing, asking all sorts of questions of our SLDS system, getting interesting answers, but we have low confidence. And that low confidence can carry over, to the people involved, the departments involved, as well as the other systems. And we've seen this happen again and again. And by the way, this is not unique to SLDS systems. We've seen the same thing when we're taking a look at private sector. We're going through and trying to find, fraud, or trying to work with a university to do a healthcare study. And they had done bad data matching in the past. Everyone knows about it, and then everything is cast into doubt, including the entire system that they were working on. So what does that kind of look like on average when we go and take a look at different SLDS systems across the states, and going through in some cases across different countries? They don't call it SLDS. That's fairly unique, but they call it typically similar things. Typically, with an SLDS system, you are finding about 90% of your potential matches. Sometimes that varies depending upon what kind of software you're using, and we'll take you through some benchmarks later. But that's at a high level. So overall, we're missing about 10% of our matches. And that's been remarkably consistent when we've gone through. It's a little bit higher with homegrown systems. It's about, perhaps 25–30% of the matches are missed. We've seen that consistently with in-house solutions. Typically only about 8 or 9% compared to other software solutions where they're not missing quite as much. They might be finding 92% of the potential matches. But that's at a high level. That's at the overall state level, and that's not spread evenly across the geography or across the population and the groups within that population. When we get into the county or the city, it can be much lower, just like the Tale of Two Cities, where about half of the matches for that particular city, which was a large city, it was over 100,000 people, came up. Another thing that we've noticed is that false matches are typically ignored. Typically, when record linkage is conducted and you have the matches between Department of Labor and Department of Education, it's provided in a mass dump, maybe a gigantic CSV file, etc., if it's really reviewed at all. And there's typically not a very good way to review those matches. There's no user interface for the reporting people and the people who are working with that data and know the most about those systems to go in and review to see, well, are these matches good or are they bad? And also, how would I know? What's the matching score, etc. Oftentimes, they're going through and relying on, maybe one algorithm, maybe an algorithm developed internally or developed by a partner at the local state university. But at that level, graphic user interfaces, etc., to review these things, aren't common. Also, typically, the matching algorithms are done in somewhat of an ad hoc manner. Someone goes out and takes a look at, okay, I'm going to use a double metaphone algorithm or a Jarrow-Winkler algorithm or a variety of other algorithms to do my matching because it's available, it's out there, it's something they understand, but they don't have the time or the ability to go in and audit what they've done or take a look and see, is there other approaches or multiple approaches that will get a better end result. And we'll talk through those as we get through the presentation. Also, does this really match up to how a person would view similarity, or is it missing a lot of those potential matches that we reviewed in the Jenny Smith example? Typically, everyone's looking at just one match definition, one way of defining matches. A great benchmark here. There's a very commonly used intrastate, high school to college attendance matching system. We consistently find 10% more matches than that system, and this is a system that the majority of the states and territories are using. Just to give you one example, in one case, going through and taking a look at higher education versus K through 12, saw a 35.3% match rate. Before, after we went in, took a look with our software, 38.3% was what we found, about 10% more matches. So just so everybody, and we're being transparent about what we mean by finding more matches and what's the impact on the rate. So not a very potentially large issue when you take a look at the state level, but when you start diving into the populations and the cities, you have more and more tale of two cities type examples. Now, with that, we're going to get into why are minorities missed more often in matching. We don't want you to take our word for it. We want to walk you through some of the examples and some research that is not done by us, done by outside government institutions, etc. Now, the first thing, because talking about this subject, it can be sensitive. Just to let people know, we're looking at this from a kind of a worldwide perspective because we've seen this in other countries. For our definition here, a minority is an underrepresented group in a population. So if a person of French descent is in China or a person from China is in France, we would consider that to be a minority population for these purposes. And they'll start to make sense as we talk through the examples. Also, names in different groups change more often. Women will change their name more often when getting married than men. We also see a lot with minority groups going through and trying to change their name so it's easier to say or sound out. This example, Setsapan, very common name when you start taking a look at Poland, the Ukraine, etc. But when they go through and they become, over time, they typically want to change their name to go through and make it easier for people to pronounce, etc. And Setsapan becomes Steve, etc. All of these kinds of nicknames, we have tens of thousands of nicknames and relationships like this documented in our database for a wide variety of countries. Another piece, and you'll see this the most often, say you're dealing with an Indian call center and you go through and someone has an Indian accent, they say, my name is Bill. You know very certainly that their name is not Bill. They're simply saying that to try to make it easier for you to pronounce. And by the way, that will change depending upon what country they're going and talking to. Immigrant groups are about 2 to 5 times more likely to change their last name as well than average. So it's not even just a first name issue, which is understandable and also very common. Even with something like the last name, it's 2 to 5 times more likely. The study that we reference here, and anyone please let us know, we'll go through and send you a link to the study. We've got hyperlinked within the presentation. This was actually a Swedish study that went through and did a lot of great work to find this out. If you go through and you do data matching and you deal with those studies, you probably have encountered this or had a feeling that you might be missing something. And this was the best research that we were able to find done at a country level, an entire country, and it was 2 to 5 times more likely. So if you're going through and doing simple matching techniques or using standardized software or IBM, SAS, etc., a lot of these things are going to be missed. Now, the 2 to 5 times more likely, that is on official government surname. So that is actually going to the government and saying, okay, my surname has changed from X to Y. As you might believe, it's much more common for people just to kind of change it on their own and not necessarily register it themselves. Particularly if you're dealing with a first generation group coming in. They'll start going by a different name, but they're not going to officially change it. You start getting second generation, etc. They'll go through and officially change it. Another piece, life events at a different rate. One of these pieces, and we'll go through this in the next slide, differences in age at first marriage. Marriage and divorce is one of the most common changes of names, first and last. that people encounter, obviously. And I'm sure probably everybody on the phone has encountered that within their databases. But sometimes there's a big difference in the group that goes through and gets married by a certain age. And this is important because a lot of critical things are happening with data when you're taking a look at someone around the 20-year-old range. We'll go through that in the next slide. Again, women more likely to change last name than men, 70 to 81%, depending upon what country you're looking at, than men, which is really only about 1 to 3% of men change their last name. So by no means is it just women or just men, but it's predominantly women. But even men, many times this is something that people might not be aware of, that this is actually very commonplace. Some countries, the UK, it's actually becoming more and more common, which is actually where the 3% comes from at the high end of the range. Now, when that last name is changed, it's not changed in a consistent way. Sometimes the name is just changed completely. Sometimes there's hyphenation going on, etc. Another piece is that nicknames are not necessarily well understood when you're going through and you're taking a look at any kind of minority population. Now, even with well-known names, Margaret, a nickname for Margaret is Peggy. There's actually about 80 different nicknames associated with Margaret that we have documented in our database. And that's a fairly common one, but even one that people might not be that familiar with in general. But there's other ones that you might not be aware of, depending really upon where you are. Shalina and Lena, big nickname. Mocha, Maria, a Croatian example. And many of these examples are actually things that we've seen in different minority groups, and they were the root cause of why certain matches were missed. When we started talking about the finding 10% more matches, these are some examples of how nicknames affect that. But then we think about William equals Bill. That's one. United States, UK, that's fairly universal. Everyone would know that and be able to find that match and have that match. But there's a much wider variety now when we start taking a look at, especially the melting pot that's the US. And you have people coming in from all different places, Eastern Europe, etc., where it's not common to the overall group. Now this slide here, really just going through and getting into what we were talking about with the marriage rates and how this would affect matching. If you go through and you take a look, and we're just dividing it, typical chart, non-Hispanic, Hispanic, non-Hispanic Black, etc. And we can see there's a huge difference in the marriage rates by age. If we take a look here, we see almost 4 or 5 times more likelihood of marriage by Hispanic women by age 20. Now, that's incredibly important for SLDS systems because many times SLDS systems, you're trying to track things between K through 12, higher ed, and the labor force. Now, that time period around 20 is many times where that linkage happens. If someone goes through and you have Jenny Smith and they graduated, they went to college, still known as Jenny Smith in the database, and then went on to the workforce, Jenny Smith, still in the Department of Labor database, you have a full linkage across those 3 systems. Now, if Jenny Smith gets married, etc., you lose that linkage. And because that marriage at that age happens at a much different rate depending upon the population, and this is just breaking things down into very high level groupings, you're going to go and underrepresent those groups if you don't have confidence that you're catching this problem. And from what we've seen, many times it is not being caught just because it is somewhat difficult Now, as we start getting into, why are you missing 10% of the matches or more, really the big piece of this is, and what we're trying to do is have human decisions at computer speed in terms of the matching. So we want to automate the way a person would view the match. Now, the mistake that is typically made and why a lot of these systems don't catch the matches is they don't look at it the way that a person does. Many times, if you go through homegrown solutions as well as the higher-end software packages, many times miss this, where they go through and say, okay, the solution to this is an algorithm. It's Jarl-Winkler, it's phonetic, etc. But the thing is that that's not the way people do a match once you start really thinking about it. If you start thinking about how you view a match, you view it based upon patterns. And if you just think about the way that you grew up, from a child to an adult, first you learn how things sound. And this gives us our phonetic algorithms. And we use and constantly research and improve our phonetic algorithms. But at the same time, that's not everything. Because then you learn how to read and write. And that's really what gives us our fuzzy matching algorithms. Are we seeing that something has the same characters, is spelled similarly, etc. But even those two very high-level things, and there's all sorts of other things within fuzzy matching and phonetic matching in terms of dealing with empty values and dealing with abbreviations and acronyms and semantics, etc. But even if we just take a look at those two high-level things, there's even more than that. So we know how things sound, we know how to read and write, but then think about numbers. This is just a completely other area, and we take a look at the number 99 and the number 100. They are not spelled the same. They don't use any of the same characters, but they're 99% similar. These are the kinds of things that we go through and constantly think about and refine and improve upon to make sure we can find all of the matches. Those are just the high levels. If you think about many other aspects of similarity that you learn over time. Nicknames, you might learn, okay, William is Bill, etc., and you go through and you kind of learn that over time. But you're just learning that for your own group. You might not understand what those nicknames would be from people from very different countries than where you were born. There's other domain-specific expertise, libraries, etc. Town names. Sometimes the exact same place can be referred to by two different names. One is the official town name, one is the old neighborhood name from 200 years ago that everyone still uses. Now, the thing is, your brain and the human brain is just excellent at dealing with this kind of pattern matching. It does all of this simultaneously, and it's not just one algorithm. It's an overall approach that your brain uses, and this is what our software is designed to do and operate the same way. And of course, be able to optimize that in memory processing, NoSQL databases, multiple cores, etc. Constantly test and improve these algorithms, as well as just the workflow, just the simple things of what's the best place to put a button for people to click or review to improve our match percentage, both in terms of finding all the matches that are there, as well as avoiding the false positives and making sure we don't say that a person is a match when in fact they are not. Constantly update our nickname libraries. We actually just doubled the size of that this year as we expand. And this what leads to at least 5 to 10% more matches than any other software, so we can help people get the most out of their data and the most out of the SLDS system. Because if you're missing these matches, you run the risk of a Tale of Two Cities type example. Might not happen right away, might not happen for years, but when it does happen, it can be quite an issue, and plus you're just making bad policy decisions in the meantime. So some quick look at what we're going through and taking a look at. When we go through and we have an input, we take a look at all sorts of things in terms of similarity scores, custom scores, binary values, is it yes or is it no, numeric input. We also take a look to see, is there anything missing? Is there a missing last name or a missing first name? How does that depend on things? And that goes through and allows us to vary our methodology depending upon what information is provided. So that's what gets us to DataMatch Enterprise at this level. The next piece, dependencies, when we take a look at covered patterns and data, gets us to an overall aggregate score. And a lot of this is customized depending upon what you're looking at. We've got different thresholds, weights, patterns, and we try and endeavor to do this as intuitively as humans. Now, as I had talked about, we have different benchmarks from all the approaches that we go through. We've gone through benchmarking studies that have been done at the university level. We've also done benchmarking exercises of our implementations post in-house solutions. So we're able to take a look at a lot of differences in the match accuracy. Now here's where we are, 96% match accuracy. Now many times people say, well, I have 99% match accuracy. I have 100% match accuracy. Any time a metric like that is thrown out is usually looking at, a different thing, or truly just an untested method. Many times we have encountered people who think they have encountered 100% of the matches because they found all the matches they expected to, but then they had a lot of false positives. Now, this 96% takes into account a punishment for when you find a false positive. IBM quality stage, which is really the next best that we've seen in the world, and we've seen this result consistently between our own tests as well as university-sponsored tests that were independent and non-sponsored. So we know that we were able to capture 5% more than IBM, which is the next best in the world. Excellent package, excellent company, but does not concentrate on data matching. That is not all that IBM does. They do a great number of things. One of the most interesting pieces is the in-house development, where we've seen consistent match accuracy, typically below what you'd expect, IBM and SAS, which logically makes sense. The people who are going through and doing in-house development typically, have another job when they start, etc., and also do not have people who are going to be full-time dedicated. Another piece that we've noticed in about half of the cases where they have an in-house solution, the person who developed it, the person who understood it, left the company, whether that was now or 5 years ago. Now that's just looking at the match accuracy. Another piece is we concentrate a great deal on software speed. If you're going to go through and improve your matches, you need to have a way of reviewing them, and you need to have a way of conducting matches fast. If you have to go through and submit a routine and wait over the weekend or overnight to get a match result back, you're only able to iterate and learn from the experience one time within that day. As opposed to if you have 30 minutes and you're able to get the same results within 30 minutes or 2 minutes and have those results very quickly, you get a much, much larger number of iterations that you can learn from. And you can see, okay, I'm still getting these bad matches that I don't like, I'm getting these other good matches. Let's go through and let's refine the methodology. And we've walked our clients through that. In many cases, we actually simply go through the process for our clients and help them get higher and higher levels of match accuracy when they're looking. Another piece is the licensing costs. We always come in much lower than the competition. And another piece as well is just the time to the first result. Many times with even the higher end software companies, between the moment in time that you have that first appointment to when you actually see any kind of a result, just a first draft that you know is going to be bad, it can be months. With our software, within 2 hours, if you have the data, we put the software on top of the data, do some profiles, we're able to come up with a first pass of the matching. It's typically by no means the full cleansing and the end result that you go with, but we're able to do things that fast. And that's very important. That's why we're able to get the match accuracy in addition to all the other things I mentioned before. Now, at this point, we'll go through, and I'd like to just open it up for questions. Feel free to type your questions in the chat as well. you can have come over to us, and we'll go through and discuss them. But also with that, I just wanted to thank everybody for their time in going through the presentation today. Here's our contact info if you'd like to contact us for any reason, even just learning about data matching a little bit more, or helping to show you the right direction, questions around the studies that we have, feel free to let us know. Another thing that we commonly encounter is going through, and even for our non-clients, we'll go in and talk with those who are making the policy decisions, who might not understand the impacts of bad data matching. Sometimes you have a lot of organizations saying, well, if it's not the exact match, we don't want to use it, and we'll eliminate those results. And they don't understand how that's just going to destroy the quality of the reporting and lead to a tale of two cities type example. So anything like that, please let us know. With that, go through and open it up to questions. Feel free to type the questions in the chat, and we'll go through and get through them. What we got? We've got one. Okay, one question that we see in here is, how do you know the match accuracy for the in-house solutions? Which is a great question. We go through and we do essentially an audit of ourselves. It's kind of part of the process. But then we compare the matches that were found in the previous system, whether it was that in-house system or another software, and they'll look at the matches that we found. And we're doing this for two cases. One, what matches were found by the other system that weren't found by us, and what matches did we find that the system originally missed. So that's how we're able to go through and identify those. And we also go through a fairly in-depth process of trying to identify false positives. So matching and finding everything that should be a match is just one side. The other side is, if there are false positives, that also punishes the score. So if there are 100 records, 100 possible matches, we found all 100, but we also found another match that shouldn't have been a match, we would go through and give ourselves a 99% versus 100 on that, which is the other question. With that, any other questions? Got one other being submitted now. Have we worked with any other kinds of data sets within the states as far as workforce data quality, etc.? We've worked a great deal with different agencies within the states. And sometimes, as you know, even the SLDS system is not necessarily called out as, the Department of Education. Sometimes it's something different. Sometimes it's actually an effort led by Department of Labor, depending upon how the state is going and looking at that. But some other very common examples of what we look at from an education arena is also linking in things like test scores, particularly ones in the past that were read via OCR, optical character recognition, and have a lot of problems when you're trying to do the record linkage. In those cases, we're usually able to find 50% more matches than the previous systems. Great. One other piece. This is a great question. One of the times, many times the in-house budget solution is due to budget, or the top points you recommend to help put into a budget request. That's a great question. Overall, typically, if you take a look at the total size of the SLDS implementations, they're millions of dollars, and you have many dedicated people on top of that within your own organization to make that system happen. if you have poor data matching, it puts that entire system at risk, especially with how critical really everyone has become of education because of Common Core, etc. Many times it's risk avoidance. But the other piece is if you're going through, and it's not just the SLDS system, which is millions of dollars. If you have potentially billions of dollars in education budget, if you go through and take a look at the complete picture for your state, if you're not allocating that in the right way, you're going to be putting the money in the wrong places. Another piece as well that we've seen is in many of our implementations, it's actually ended up being a net no cost. The reason for that, they had typically hundreds of consulting hours gone through and budgeted for the data matching exercise to be done manually and be reviewed, and we were able to step in with the software in our overall approach and cut those hours way, way down, and we got a much better result, and many times actually a cost savings on the overall SLDS project. But one of the biggest pieces that I honestly think is many times system implementations fail. SLDS systems are no different. And if you go through and do a system implementation and then doubt is cast into that system implementation, we've seen large system implementations fail due to bad data quality, bad data matching. Probably about 15% on average between the private sector and the government sector as a root cause. It's probably twice that amount when you take a look at all of the possible reasons. But many times it's the bad data quality, and it's the bad data quality between systems, between a system like Department of Education and Department of Labor that are not on the same system and are managed by different people with very different goals. And that's something that we've consistently seen. Any other questions? Another question here. We say that bad data matching with our SLDS system hurts the opportunities for young Latinos. From what we've seen, it is disproportionately more bad matches within the Latino population, depending upon what state they're in. And again, this comes down to the idea of a minority. In many states, Latinos wouldn't be considered a minority or within a particular city because they make up, the plurality or, a large portion of the population, and people are used to, the different naming conventions, etc., and can go through and spell the names when they do the data entry, etc. But, we have seen it disproportionately affect Latin Americans within the U.S. You go through, you take a look at other countries, you actually sometimes get the reverse situation. Another question, we have trials available. Yes, we have trials available, and probably more importantly, we have solution specialists that can go through and walk you through the data matching. And by the way, this system, this is not software as a service. This is all local installs, heavily secure, does not make any calls out to the internet. So many times we're walking people through their data, and in some cases we can't even see their data. We're just kind of talking it through with them on the phone. And of course, in many cases, we're on site and sometimes just in a locked room looking at data, trying to find better data matches, etc. The security of this kind of information is paramount, but this system, etc., is all very, very secure, and it's all installed locally, within your own firewall, with all the other security that entails as well. So none of this, none of this information or our system goes out, to the web or the cloud or anything like that. It's all hyper secure. All right. Any other questions? All right. Well, those were great questions, and just wanted to thank everybody for their time today, and feel free to contact us if you have any questions, whether it's about our product, etc., or even just data matching in general, or helping to talk with your management team and help them understand the kinds of issues that are involved with data matching, and that it's not just them, it's an overall problem that just happens in living, breathing databases. But with that, thank you very much for your time this afternoon, and feel free to contact us.